All right, now we're on to the other graphic organizer we're learning about besides box plots. Now we're on to what are called line plots, also known as dot plots sometimes. Just like the box plots, which always dealt with like median and range, looking at the spread of the data, and they wanted the median of the first half and the median of the second half of the data. They kept wanting the middle. This is also a graphic organizer thrown down on a number line. So we're going to use a number line to place our data on. And we're going to look, and this gives you a little bit more. It does show you the spread. You can see where the data is kind of mostly located and how it's spread out and stuff. So I like that. But it also gives you other things that the box plot can't. So box plots can give you the spread. It gives you the kind of where the data is, but also the median. But this specifically tells you exactly what the data is and where it is on the number line. So you can actually see the data. If I didn't show you all those test scores from the other video, then when you look at the box plot, you can't see even how many test scores there are. Okay, so like unless you see the actual data, you wouldn't have even been able to know that, oh, okay, it was only 7 at first, 7 students test scores. Here on a dot plot, you just count your dots, okay? Or you count the data values if they show you the data, and you'll see that this is a class of 23 students, supposedly. And these 23 students' test scores are listed out here. You certainly could put them in least to greatest order, especially if they later ask you for the median. That is something where you may not want to use the dots. Some kids get a little confused with that, so they just handwrite and put them in least to greatest order and scratch it out. Being an odd number of numbers, there's going to be that one number in the middle, which we'll get to and I'll ask about in a little bit. But for a dot plot, you don't even really need to put them in order because the number line does it for you. Okay, so all I do is when I find 84, what I did is I put a dot above 84. And then when I saw another 84, I just put a dot above that and I'm stacking them. Now you want to make sure, I'm not always the best example, of keeping it organized to where literally there are rows that are created here so that you don't have some really far apart going up and down and others really squeezed together. You want to kind of keep them evenly spaced so you can really see the highest peak and things like that. Sorry, mine looks like the Leaning Tower piece over here. I would claim that you can see the board is warped and it's all the board's fault, but we know better. We know that my handwriting can be a little sloppy. All right, so what I did is I put all those numbers down on the number line, not on it, but above it. And then once I put them all down, I can kind of see something about this class. Okay, so right away, what I'm getting out of this is that most of the kids, the cluster, the main group of the test scores are on the high end. Makes me excited as a teacher. You got a lot of kids who are in that 94 to 100 range. That's where most of it is. The peak, the highest point, way to go, is on the 100%, where you can see, we'll get to mode, that's what happened the most. That's what occurred the most. That test score came up the most. You can see other things like there were some gaps in there. We didn't really talk about outliers back when we were learning about mean and median. That would have been really good to talk about. But you can see there are no outliers. Outliers are just data values that just stand out and are so different from the rest. So an outlier in this case would have been if this class all got these scores and then maybe this one kid here at 79%, between 78 and 80, messed up, didn't do very well, and ended up with like a 40 something, right? A 46. That would be an outlier. Okay, so that outlier, if that was true, would totally change the mean of this class. It would affect the mean a lot more than it would the median. Okay, so the middle would actually stay the same, but the mean would be altered more. And I wish I'd have had more time to go into that in detail. Some of the things we're missing with this at-home learning. But what we're going to do here is also look at the spread. We said that the box plot does that, but so does the dot plot. So you can see that it's from 79, the worst score of this test, to 100, the best score, which happened repeatedly. Did you notice, by the way, that all of these numbers on the number line are being counted by 2 because all the data ended up being even numbers except for that 79? Probably means it was like a 50 question quiz. Each one's worth 2 points. and maybe this one kid forgot to label his units or something, or just got a half off or something. I don't know. I'm making all this stuff up anyways. Okay, so at this point, some of the things they may ask you on the test is, okay, well, what's the mean? You can't find the mean in a box plot. The data's not all revealed. But in a dot plot, you can, and it's horrible if there's numbers that are this big and this many of them. So and remember, it was very important that there were 23 students, right? So you need to make sure when you create your dot plot that you have the matching number of values on there. So I counted all my dots, and I had 23 dots and 23 numbers. It matches. That makes me feel better. All right, now I know I'm probably going to be okay. So when you do the mean, you literally would add up every one of these values. Okay, so remember this dot right here, I'm just going to make that one up right there. That dot right there is a 90. One of 3 different kids who got a 90%. So I would literally add up the value of every one of those dots. And I did with the calculator. And I ended up getting a sum of 2,131. That's the total amount of points for this whole class on this quiz. Then, of course, for mean, you would divide it by how many numbers you added, which were 23 different scores. So over here, you can see my division, and 23 went into 2,131 92 times. And there was a remainder of 15 out of 23. Since my remainder was greater than a half of what it took to make a group, right? That was 92 equal-sized groups with 15 points left over. I could not make another whole group of a points up. So this 15 out of 23 is over a half, because half of 23 is like 11 and a half, right? And that's 15. I'm going to round that up. And that's what all teachers usually do, is they would just round that using the rounding rules. Remember, if it's half or more, you round up. Below half, you round down. So this 92 would round up, and I would say my mean for my class was just about a 93%. Not bad. Not bad at all. So the average student, typical student, measure of center, 93. Now for the median, remember there's an odd number of numbers. That's good. That's good. The number line organizes us. So watch this. I'm going to kind of go a little slower here. You're going to do that whole cross out of least and greatest. Okay. Now what gets confusing is there's a bunch of 100s over here. Hey, they're all the same number. Doesn't matter which one you scratch out as long as you work from all of those least greatest principles here. So watch. So my least score of all was 79. My greatest, doesn't matter which one I go with, is 100. Any of those hundreds would be fine. Okay, then my next least was 80, 100, 82, another 100, 84, 100, 84, 100, 88, 100, 88, 98. Then I'm going to take out a 90, 98, a 90, a 98, a 90, 96. Take out a 94 and a 96, and look what's sitting right here. The median, the typical score, which is also outstanding for this class, was a 96%. Those are 2 different measures of center that are not too far off, but they do show you they're a little different. You can see that a lot of the data was clustered up here in the high end. That's probably why the median's here, whereas the mean was affected by these lower scores and brought down a little bit. Okay, the mode, clear. Look at that peak. Look at the highest point. 100 happened 6 times. So watch out. The answer is not 6. Okay, that is how many times 100% occurred. So mode is the number that occurs most often. And that number was, thank goodness for me as a teacher, love seeing that. More thank goodness for the students. This is all fake anyways. Okay, 100%. So the mode was 100%. That happened the most. Okay, not 6. That 6 is the work that shows the 100% happened the most. Okay, the range, last one here. Just take the greatest, 100, subtract it from 79. Not going to show you that work because I think you're all good at that. That is a 21% range, spread of data. So it's a 21% difference between the greatest and the least scores. So this is a dot plot, also sometimes known as a line plot, which you'll hear me say more. So dot plot, line plot, synonymous. Sometimes they don't use dots, they use X's. Don't be confused, it's the same business. Okay, real quick, this was Module 16, Lesson 4, just following right after what preceded was the box plot lesson. Now we're on dot plots, line plots. And I have a few quick jokes to share with you. All right, so what does a nosy pepper do? It gets jalapeno business, all up in jalapeno business, all up in your business. All right, why can't you explain puns to kleptomaniacs? Okay, the answer is they always take things literally. Okay, so a man tells his doctor, "Doc, help me. I'm addicted to Twitter." The doctor replies, "Sorry, I don't follow you." This one resonates with me at home. What kind of exercise do lazy people do? Diddly squats. All right. And the last one, oh, this one's not funny. It actually strikes a nerve. What do you call a parade of rabbits hopping backwards? The answer is not very funny. A receding hairline.